Hi to all, welcome to Chemistry Online. So, yesterday we started solid state. What we discussed means characteristics of solids, types of solids, and types of crystalline solids we discussed. Now we are going to discuss X-ray crystallography. X-ray crystallography. X-ray crystallography. So, if it is your question, what's the need of discussing X-ray crystallography? If you want to know the structure of solids, then you must know about X-ray crystallography. X-ray crystallography tells about the structure of solids. X-ray crystallography tells about the structure of solids. Okay. Then I am taking a crystal. So this is a crystal having atoms or molecules or ions are called, it is a lattice, is nothing but a crystal. These are lattice points or lattice sites. So it is a lattice. These are lattice points, or lattice sites, atoms. So according to Max van Leeuw, Max van Leeuw Leeuw 1912 works on crystallography. So when he said that when if you passed X-rays through the crystal lattice, then the beam of light strikes the atoms or ions or molecules present in the crystal, then they are diffracted. So when light falls on the crystal is nothing but an incident light and touches the points and then come back, means again it reflected, that is nothing but reflected. That incident light reflecting is nothing but a diffraction. Why X-rays undergo diffraction means they undergo interference. Interference may be two types, constructive and destructive. If you pass two waves, two X-rays, when they are in same phase, they undergo constructive interference. The waves are in different phase, they undergo destructive interference. Now I am going to show constructive interference and destructive interference. First, constructive interference. Constructive interference. And it is nothing but a destructive interference. So passing two waves, so it is nothing but a one wave. It is a propagation. Propagation means moving. It having amplitude like this. It having a amplitude like this. So here it is AW1 means amplitude of wave 1. Then I am going to take one more wave. Okay, it is a propagation. It is nothing but a amplitude of wave 2. Amplitude of wave 2. When they are in phase, the waves, both waves are in phase, their amplitude resultant wave is now it is a resultant wave. Okay, this is AR. AR means AW1 plus AW2. This is the first wave. First wave. It is the second wave. It is the resultant wave. Resultant wave. Then the waves are in phase. Two waves. Both waves are in phase. In phase, they undergo constructive interference. Okay. Next, destructive interference. So this is the propagation of the wave. Propagation wave is like this. Wave is like this. It is AW1 amplitude of wave 1. Next, one more wave I am taking. Like this. It is also propagation. It is the amplitude of wave 2. And then resultant wave is like this. So it is a resultant wave. AR. It is AW1. It is AW2. Cancel with each other. Then they undergo destructive interference. Both waves are in different phase. Different phase. Understand? According to Max van Leeuw, if you pass X-rays through the crystal plane, the X-rays are diffracted from the lattice points. The diffraction may be, why the diffraction? Why X-rays undergoes diffraction means they undergo interference. Interference means that is two types, constructive interference and destructive interference. When constructive interference means if you pass two waves, the waves are in phase, they undergo constructive interference. The waves are in out of phase, they undergo destructive interference. So this is about constructive interference and this is about destructive interference. This is about destructive interference. Based on this work, Bragg's W.H. Bragg and W.L. Bragg derived equation. Okay, the equation which gives relation between d, distance between the planes, lambda, wavelength, and diffraction, n, order of diffraction. Now we are going to discuss what is Bragg's equation. Got it? Very important. Next topic we are going to discuss. That is for 4 marks. This is constructive interference and this is destructive interference. Okay. Next, very important question, Bragg's equation. Okay, so WH Bragg and WH Bragg and WL Bragg derived Bragg's equation. Derived Bragg's equation. Which gives relation between D and D, comma lambda and theta. So D is the distance between the two planes, lambda is the wavelength of X-rays, theta is the angle of incidence or reflection. WH Bragg and WL Bragg derived Bragg's equation which gives relation between D, lambda and theta. Now he is taking a plane, crystal. It is a crystal lattice. Is taking the crystal lattice. Okay, these are points or atoms. This is the first plane, it is the second plane, it is the third plane. Okay, the crystal is a crystal substance which having crystal lattice. It is crystal lattice. It is a crystal lattice which having three planes. If you pass X-rays through this crystal plane, the X-rays undergoes diffraction. So like this, when touches the points in the crystal plane and they undergo diffraction. Like this, it is a first X-ray which undergo diffraction. The point is I am taking A. It is a incident and it is a diffraction. Next, second X-ray touches this point and undergo diffraction. It is a second X-ray. This point is I am taking as a B. Now this distance is called D. I am taking as a D. So here it is the distance between the two planes. I am taking as a D. D is nothing but a AB. So AB equal to D. Then so here first and second ray travels same distance up to C, and first and second ray diffracted same distance from D. What I mean to say, if you pass two X-rays up to AC, they travel same distance. From BD they are diffracted same distance. So second X-ray traveled extra distance, that is nothing but BC plus BD or not. Okay. So here, so second X-ray traveled extra distance that is BC plus BD. Okay. When the waves are in phase, they undergo constructive interference. Then the path difference between the two planes, the wavelength means the path, the distance between the two planes is an integral multiple of n lambda. Okay. Second X-ray travel extra distance, that is BC plus BD. Now BC plus BD is equal to n lambda. Why? Because the waves are in phase, they undergo constructive interference. So BC plus BD equal to n lambda. BC plus BD equal to n lambda. This is I am taking 1. Why BC plus BD equal to n lambda means they undergo constructive interference. Their path difference between the two X-rays is equal to an integral multiple of their wavelength. The distance between the two planes is an integral multiple of wavelength of X-rays passing through the crystal. Then BC plus BD equal to n lambda. So here we have to calculate BC and BD. See, from the figure, two triangles we have, ABC, ABD. In ABC, it is theta and it is theta. Here sin theta is equal to opposite side by hypotenuse, means BC by AB. AB equal to we know D. And then sin theta equal to BC by D. So BC equal to D sin theta. This is equation 2. Okay. Then in one more triangle ABD, in ABD, this is a triangle ABC and it is in triangle ABD, sin theta equal to, it is a sin theta. This is equal to opposite side by hypotenuse. Opposite side means BD, by hypotenuse means AB. Then AB equal to D, you know. Distance between the two planes. Then what happened? Sin theta equal to BD by D. Then D sin theta. Then BD equal to D sin theta. This is equation 3. Okay. 2 and 3 in 1. Substitute 2 and 3 in equation 1. Okay. Then BC plus BD equal to n lambda. BC plus BD equal to n lambda. BC means D sin theta. D sin theta plus D sin theta equal to n lambda. Then it is 2d sin theta equal to n lambda. Then d equal to what happened? D equal to n lambda by 2 sin theta. 2 sin theta. This is Bragg's equation. It is a Bragg's equation. It is a Bragg's 2d sin theta equal to n lambda. So d equal to n lambda by 2 sin theta. Here you have to know what is a d. D equal to distance between the two planes. Distance between the two planes. N equal to order of diffraction. Order of diffraction. Then lambda equal to wavelength of X-rays. Wavelength of X-rays. Next, theta equal to angle of diffraction. Angle of diffraction, that is incident or reflect. Incident or reflect. It is briefly Bragg's equation. So it is a very important for for 4 marks, 3-star question. Very important for 4 marks. Okay. So this is the way. Okay, understand? So the man W.H. Bragg and W.L. Bragg both are father and a son. On combined study of father and son, they give Bragg's equation, which gives a relation between d, distance between the two planes, lambda, wavelength of X-rays, and theta is nothing but a angle of incident, angle of diffraction. Incidents are a reflection. Now it is a crystal lattice I am taking. These are lattice points. Then if you pass 2 X-rays through the crystal plane, they are diffracted from the lattice points present in the crystal. The diffraction may be 2 types, already I told you. Why they are diffracted means they are due to interference. Interference may be constructive and destructive. Here constructive interference, they undergo constructive interference, then only we will see the points, we will observe the points. Then so here the first X-ray diffracted from A, second X-ray diffracted from B. If you see these 2 waves, second X-ray is traveled more distance, second X-ray traveled extra distance, that is BC plus BD. So the distance BC plus BD is equal to n lambda. Why it is n lambda means the waves undergo constructive interference. Due to constructive interference, the path difference between the 2 X-rays is nothing but integral multiple of their wavelength. So BC plus BD equal to n lambda. From the figure here, in triangle ABC, angle sin theta we have to calculate. In triangle ABD sin theta we have to calculate. Then sin theta means we substitute 2 and 3 in equation 1. Then you will get a 2d sin theta equal to n lambda. So d equal to n lambda by 2 sin theta. So here d is nothing but distance between the two planes. N equal to order of diffraction. Lambda equal to wavelength of X-rays which we are passing through the crystal plane. Theta is angle of diffraction, that is maybe incident or a reflection. So this is the way. Okay. So here lattice, crystal lattice contains these points are called crystal, means lattice points or lattice sites. Okay. Why the diffraction means X-rays undergo diffraction means on touching light of beam, we are passing light of beam, on touching these points they undergo diffraction. They undergo diffraction. Okay. So this is today our topic. Stand by.